Hey, what's going on, guys? So, this is one of the last portions of solving a system of linear equations. Now, this is a more difficult type of problem because we're going to be solving a system with three variables. Normally, we've been dealing with x and y's. Today, right now, we're going to deal with x, y's, and z's. Now, one of those things that kids always talk about in math class, and kids always complain because they say that when you get really far in math, you have problems that take up a whole entire page. Well, sad to say, but this is one of those examples. Not because it's hard, but because it's just a lot of work. All right? So, what we want to do is we need to solve this system. All right. So, what we want to do is basically cancel out one variable in every single equation. All right. Now, if we look here, we have x minus 2y plus 3z equals 7, 4x plus 2y plus 2z equals 8, negative 3x plus 2y minus 2z equals negative 10. If you notice, all of our y's have a coefficient of 2. So that's very, very nice because it helps us out in simplifying them. All right. What we're going to do is cancel out all the y's, so we're just left with two variables. So if we look here, we have this first equation, second equation. Since it's minus 2y and a positive 2y, to eliminate them, we're going to add the equations together. I'm going to add them down here, though. So x plus 4x is 5x. Negative 2 plus a positive 2 is 0. 3z plus 2z is 5z. 7 plus 8 is 15. All right. Now what I need to do is I'm going to rewrite the top equation over here. Okay, and then I'm just going to rewrite the bottom equation underneath it. Okay, so now, again, what we must do to both of these equations is add them to cancel out the two y's. So x plus a negative 3 is negative 2x. Negative 2y plus 2y is 0. 3z plus a negative 2z is just plus 1z, which is equal to negative 3. All right, so now we have a system of two equations. Now you can solve this any way you would like. You can solve it using elimination. You can solve it using substitution. Whatever you enjoy or whatever you prefer. All right, what I would like to do is I'm going to solve this using substitution. So I'm going to get this z by itself. So I'm going to add 2x, add 2x. So it becomes z equals 2x minus 3. I can take this whole quantity, substitute it in there. So now it's going to become 5x plus 5 times 2x minus 3 is equal to 15. So 5x plus 10x minus 15 is equal to 15. We get 15x minus 15 is equal to 15. Add 15 to both sides. We get 15x equals 30. Divide both sides by 15. And x equals 2. All right. That is one variable. So we know that x is equal to 2. Now, just like every other problem, once you find x is equal to 2, we need to substitute that to find another variable. So we can just go back to this equation where z is equal to 2 times 2 minus 3. Z is equal to 4 minus 3. Z is equal to 1. Well, now that we found z and x, we need to find a y. So what we can do is use one of our original three equations to substitute both those numbers in. I'll use this equation because it's right there. So we're going to take z, plug it in there. We're going to take 2, substitute in there, and we're going to have to solve for y. So our equation is negative 3 times 2 plus 2y minus 2 times 1 is equal to negative 10. All right, I know that's a lot of work, so we're going to simplify it. Negative 6 plus 2y minus 2 equals negative 10. 2y minus 8 equals negative 10. 2y, we gotta add 8. Sorry, I'm just getting really excited because it's a lot of fun. Equals negative 2 divided by 2. Y equals negative 1. So we know that our x is 2, y is negative 1, z is positive 1. So our solution is 2, comma negative 1, comma 1. Basically, when you solve a system of 3 equations, you're going to eliminate one of the variables using elimination. That way you get 2 equations. Then you're going to solve it just like you would a system of 2 equations. Now, this is very, very difficult. Not because the idea, concept, all that mumbo-jumbo is hard, but there's just so much bookkeeping going on here that I even got a little messy. All right? That's the hardest problem when it comes to solving a system of 3 variables. I just showed this to you because it's something good to know. And we are going to go over it a little more, but we're not going to go crazy with it. All right? But just so if we ever see it again, we know it's there. So if you have any questions, come talk to me and try some of the examples.